Hello everybody, welcome to another video in our Pioneer Database tutorial series. My name is Antoine and today I'd like to talk to you a little bit more about a feature that we call the Advanced Database Inspection feature, which in my opinion is an awesome feature that gives you unlimited access to all the data that is contained within the database and is also very instrumental in actually digging deeper into the data that you're plotting and understanding more the nuances of differences between the experiments that you're comparing to. To start off this tutorial, I will first assume you already have visited and loaded up the Pioneer database application in your browser. Otherwise, you would first need to visit db.co2pioneer.eu. I will also provide this link in the video description. It will take a little bit for the whole application to load, not only the interface but also the data from the database itself. Once the whole application has been loaded, you'll be presented with a view similar to what I'm showing here now, with a default graph showing the SEI versus the conversion of CO2. However, up top you also have access to a different view, the Advanced Database Inspection tab, which contains the whole pivot table I will be talking about a little bit more today. And when you initially load the website, it gives you the complete database without any filtering applied to it. The nice part about this presentation is that it allows you to very interactively already go through the data in the database. You can apply different kinds of filters, you can apply different kinds of groupings, all according to your needs of what you want to compare particular publications on. It also makes it very easy for you to, for instance, reshuffle columns simply by drag and dropping. For instance, I can put the gases column by holding the mouse all the way at the front of the table. But I can also, for instance, decide I don't need the DOI codes for now, so I can also hide them from my view to also reduce a little bit the visual clutter. So you can actually focus on what you want to be focusing on. Having said that, let's first move back to the graph interface or the graph and filtering part of the application. And let me show off what happens when you are actually also applying some filtering to this graph data. So for instance, let's restrict the display data to only show data from DVDs and also require a catalyst in some shape or form to be involved in these experiments. We apply these filters to the graph, but if we now look over to the advanced table interface again, we see that the same filters for both the X and Y, but also the source type and the catalyst type, they've all been applied to the pivot table. This again is intended to help you first explore via the graph, and once you have graphed your data and you want to have a closer look at what's actually happening, what these publications are reporting, we narrow already the display data down for you so you can immediately have the subset of data in front of you that you're actually considering. Moving on, let's go through a more concrete example of how you can use both the graph on one hand and this advanced pivot table on the other hand to go through literature data and investigate a little bit more in depth what's going on in a particular publication. So in order to do that, let me first switch back to the main interface and remove the filters I had just applied. So set the catalyst filter again to NA and also set the plasma source type filter to NA. Since I'm now plotting the SEI versus the CO2 conversion, I will also put the linear axis scale to a logarithmic axis scale for the x-axis so you can properly gauge across the full dynamic range of the SEI that we're showing, resulting in the following graph. So using this graph as a starting point, I will now go through a concrete example of how you can use both the graphical representation of the data, but also the advanced inspection features to get an understanding of what's actually in the database data and what is at the root of some of the trends that you're observing. So taking this very standard CO2 conversion versus SEI graph, we can already immediately see that there is sort of a general trend in the data with respect to how conversion scales with your energy input, and that you get sort of diminishing returns and have to put in a lot of energy to achieve significant conversion. However, we can also see that particular results actually scale favorably with respect to the bulk of the field, where, for instance, these particular radio frequency discharges, observations made by Stewig in 2020, seem to scale better with respect to the energy input than the rest of the field. However, for a lot of data, there's actually also CO2 admixed with other gases present in experiments. So we can try to, in fact, also correct for this admixture effect, which affects the SEI, by applying a normalization on the fraction of CO2 contained in the gas stream. And when we apply this normalization, we immediately see that some of the data, in fact, shifts. And the data for instance, Stewig, which I highlighted just now, falls far more in line with the general trend observed between other experiments as well, indicating to me that they have used a significant other gas along with CO2 in their experiment. Similarly, something similar might also be the case for the results obtained by Yao et al., which now pop up as outliers when we apply this normalization. So again, in this case, I have now the suspicion that they were using a significant amount of another gas in conjunction with CO2 in these experiments. However, the graph itself doesn't at face value tell me which gases or which fractions they have been using. And for that, the advanced inspection feature is very useful. So you can simply pop over to the tab and, for instance, drag and drop the auth year column to the filter criteria here on top, and easily filter on the Yao 2020 data, for instance. And I can now immediately see that they were using CO2 and argon with a very large fraction of argon, in fact, with respect to CO2. So in this case, my suspicion is confirmed. And let's also do this for Stewig. Stewig 2020 data, we again observe a similar effect, namely that they used CO2 and argon again and again, also with very high, upwards of above 99% of argon with respect to the CO2 case. So what I hope to have highlighted to you here is how you can very easily and very powerfully first explore with the graphical user interface, but then dig deeper with the data in the database itself using the advanced inspection features that give you concrete numbers to put into context the observations that you're making. The flexibility offered by the advanced inspection table goes beyond only observing the concrete values in the database. It offers more features to also filter and group the data, and is well worth your time exploring in more detail in figuring out how you can make best use of this powerful tool. And perhaps this will also be the topic of another video in the future.